Lesson 1-9, Projectile Motion. Projectile motion occurs when an object is in flight only under the influence of gravity. Free fall was also only under the influence of gravity, but that had thinking of just vertical motion. But now we can also have horizontal motion, and you can see the path of the projectile in the graph. In projectile motion, the x and y components are completely independent. The x motion does not affect the y motion. The only thing that's the same in both dimensions would be the time. The x component of the velocity is constant since nothing is pulling it sideways. So our acceleration in the x is 0. So the only equation we have with 0 acceleration with velocity and time is x equals vt. The y component does change because gravity is pulling it down. So for that one, our acceleration is the negative 9.8 meters per second squared. And we'd use the equations of kinematics. Notice at the top, there, the velocity is only in the x. At the top, the velocity in the y is 0, but the velocity in the x is whatever the total velocity was. If the starting and ending heights are the same, then we can use what's known as the range equation. R equals v0 squared sine 2 theta over g. These are all using the magnitudes, not the vector. So we don't use the pluses and minuses for direction. It's just the magnitudes of the velocity. And that's the total velocity, not a component. And the acceleration, the g, it would be positive 9.8 for Earth. A meatball with a velocity of 5 meters per second rolls off a 1 meter high table. How long does it take to hit the floor? So there's the table. Here's the meatball. It's going to go off and then projectile motion till it hits the floor. So now we actually have to do x and y components. So what do we know? Well, we know our initial velocity is only in the x. The initial velocity in the y is 0 because the meatball is moving sideways as it goes off the table. We know the initial height is at 1. And so we know our final height is when it hits the floor is 0. And the y, we know our acceleration is negative 9.8 meters per second squared. And we're looking for time. So it looks like in the y components, we have all the information we need. So we're going to look in the y's. And I think we could use d equals 1/2 at squared plus v0t plus d0. So we have 0 meters. A was negative 9.8. V0 was 0. And D0 was 1. So it simplifies to that. T is there only once, so we'll solve for that. So we'll subtract the 1 meter. Divide by the negative 4.9. The meters will cancel, leaving seconds squared. And then square root that answer. I get 0.45 seconds for the time. So a little less than half a second for this meatball to hit the floor. What was the velocity when the meatball hit the floor? Well, again, let's just write out what we had. The initial velocity in the x was 5 meters per second. The initial velocity in the y was 0 because it was traveling sideways. Initial height in the y was 1 meter. Final height was 0 meters. Acceleration was negative 9.8 meters per second squared. Now I'm looking for the velocity when it hit. Well, let's start in the x direction. In the x, there is no acceleration. So velocity is constant in the x. Thus, our final velocity in the x is 5 meters per second. We also need to find the final velocity in the y. So in the y, I think we could use v squared equals v0 squared plus 2a d minus d0. So it looks like we end up with v squared equals 19.6 meters squared per second squared. And then we take a square root. And we get, don't forget the plus or minus. We're going downwards, so it'll be a negative 4.4 meters per second, or thereabouts. But that's not the total velocity. That is telling us it's going 5 that way and 4.4 that way. We want the overall resultant velocity and an angle. So we'll have to use the Pythagorean theorem. To get the resultant velocity. So I got 6.7 meters per second, and then I need an angle. So my angle, since I know the opposite and the adjacent, I could use inverse tangent to get my angle, which is the opposite over the adjacent. Which is about 41 degrees. So I have 6.7 meters per second at 41 degrees below the horizontal. A truck, whose velocity is 11.2 meters per second, turns a corner too sharp and lost part of the load. A falling box will break if it hits the ground with velocity greater than 15 meters per second. The height of the truck bed is 1.5 meters. Will the box break? Well, here's the truck bed, and here's the box. The ground, so it's going to go sideways, and then projectile motion. So in the x, our initial velocity is 11.2. In the y, the initial velocity is 0 because the initial motion is just sideways. We know the acceleration in the y is negative 9.8 meters per second squared. We know the initial height in the y is 1.5 meters, so the final height in the y is 0 meters. And we want to compare it to a velocity, so I need to find the velocity. So in the y, I could find my velocity. So I'll get v squared is 29.4 meters squared per second squared. And so in the y, the final velocity will be negative 5.42. In the x, remember our acceleration is 0, so our final velocity would stay the same as the initial velocity. So our resultant velocity, use the Pythagorean theorem to combine the x and y components. Remember, you just use the magnitudes. And I got 12.4, or 12 meters per second. So will the box break? No, because 12 is less than 15, so the box does not break. While driving down the road, a bad guy shoots a bullet straight up into the air. There is no air resistance. Where would the bullet land? In front, behind, or on him? Bad guy's in his convertible, I assume, and he shoots the bullet up. But remember, his car is going sideways, so the bullet also has a sideways component. And so his car moves on. But each instance, the bullet still has that sideways velocity. So our velocity in the x does not change. In the y, it'll change. But in the x, it does not change. So the bullet will go up and come down, but its sideways motion stays the same. So as long as this guy, the bad guy, drives in a straight line at a constant velocity and there's no air resistance, the bullet will land on his head. Don't go shooting bullets straight up into the air. Bad idea. If a gun were fired horizontally and a bullet were dropped from the same height at the same time, which would hit the ground first? Well, the x and y don't affect each other. X and y components don't affect each other. So that means that the vertical motion is the same. So even though the bullet's going over, the vertical motion is still the same. So even though the one's traveling sideways, the vertical motion stays the same. So there is the same initial height, the same acceleration, the same initial velocity in the y, and the same final height. So by d equals 1/2 at squared plus v0t plus d0, the time is the same. Let's say a batter hits a ball at 35 degrees with a velocity of 32 meters per second. How high did the ball go? Well, in the x and the y, so here's the ball, we hit it that way, 35 degrees at 32 meters per second. So our x velocity is going to be the adjacent side of this triangle, so it'll be cosine. So our initial velocity in the x would be 32 cosine of 35, or about 26.21 meters per second. Initial velocity in the y, that's opposite the angle, so it would be sine. So it would be 32 meters per second sine of the angle, or about 18.35 meters per second. What else do we know? We know our acceleration in the y. Let's say our initial height is 0. We're looking for a final height. What else do we know? Oh, at the top of the path, the velocity is only going sideways. So our vertical velocity at the highest point, the vertical velocity is 0 because it goes all the way up to the top, has stopped, and is now coming back down. So I could look at the y motion. And I could work that out. All right, probably subtract the 336. And divide. And I get 17.2 meters for the height. So how long was the ball in the air? Let's review what we knew. The initial velocity in the x was 32 cosine 35, or about 26.2. In the y, we had the initial velocity was 32 sine 35, or about 18.4. In the y, we know our acceleration is negative 9.8 meters per second squared. We're saying we start at 0 height. Oh, when we land, we're also going to be at 0 height, and we're looking for the time. So the up and down for hitting the ground would be in the y. So let's look at the y motion. So it looks like it's d equals 1/2 at squared plus v0t plus d0. And I chose that one because that is the variables that I have. Fill in what you know. And simplify. And then I could solve by factoring. So I'm going to factor out a t. Then set each factor equal to 0. T equals 0 is not very helpful, but the other one will be. So subtract the 18.4 and then divide. And when you divide, you should get 3.8 seconds. So the ball was in the air 3.8 seconds. The other 0 comes from it went up and came down, so it was at 0 at 0 seconds, and then hit again at 3.8 seconds later. Now, how far did the ball go? Well, let's review what we know. We know our initial velocity, the x, was 32 meters per second times cosine of 35 degrees, which was about 26.2 meters per second. And the y, we knew a whole bunch of other stuff. And we just found out that our time was 3.8 seconds. Now far, we're talking sideways. I want to know that distance there. So that is the x direction. So now if I worry about the x direction, there's no acceleration, so my only formula will be d equals v0t plus d0. So my v0 is 26.2 meters per second. My time is 3.8 seconds, and let's say we started at 0 distance, and so that gets you 98 meters. So it went 98 meters sideways. Or, since it starts and stops at the same height, you could use the range equation. So r equals v0 squared sine 2 theta over g. So the initial velocity was 32. Remember, these are magnitudes. These are not components. These are not vectors. So it's 32 meters per second at the angle of 35 degrees. So I'll put the 35 in for theta. And g is 9.8 meters per second squared. And put that in my calculator, and imagine that it comes out to be 98 meters. Either way works. The range equation is only, though, when you start and stop at the same height. So d equals d0, same height.